Example 2, sketch the graph and find the domain and range of each function. So if we take a look at part A, we have f of x, which is equal to 2x minus 1. Now, if we look at this equation, this is in slope-intercept form, where we have f of x, which is equal to mx plus b, where m represents the slope, and then b represents the y-intercept. So in this example here, we can see that the slope is 2 over 1, and then our y-intercept is located at -1, and whenever we have the y-intercept, that means that the value of x is 0. So let's go ahead and take a look at the graph here. So if we graph at 0, -1, then our slope tells us to go up 1, up 2, and then to the right 1. Up 1, up 2, and then to the right 1, and so on. And therefore we've created our line, which is y, which is equal to 2x minus 1. Y is the same thing as f of x. Okay. Now what we want to do is, now that we've graphed this function, we now want to determine what is the domain and the range. So what is the domain of this function, and then what is the range of this function? So if we take a look at the domain, okay, it's all the x values on the x-axis that correspond to the graph. Well, we have an arrow at the top of the graph, and we have an arrow at the bottom of the graph, which means it's constant. That means it never ends. So we can say that the domain in interval notation is going to be -infinity to +infinity. Or if we wanted to write this in set builder notation, it would be x such that x is all real numbers. And you use that r to represent that x is all real numbers. Now, if we want to find the range of this function, so we take a look at the y-axis, and so again we have arrows going at the bottom and at the top. So therefore the range is also -infinity to +infinity, or we can write this as all the y values such that all the y's are real numbers. Next, we're going to take a look at the next graph, which is g of x, which is equal to x squared. So if we make a table to graph this function, we have our values of x, and then what is g of x. Okay, if we pick -1, and I'm sorry, -2, -1, 0, 1, and then +2. So if we plug in -2 into the function, -2 squared gives us an output of 4. -1 squared gives us an output of 1. 0 squared gives us an output of 0. 1 squared gives us an output of 1. And then 2 squared gives us an output of 4. So let's go ahead and write what this ordered pair should look like. So each ordered pair, x, g of x, is -2 and then 4, -1, +1, 0, 0, 1, and then 1, and then 2, and then 4. So if we plot each one of these points, we have -2 and then +4. And then we have -1 and 1. And then we have 0 and 0. We have 1 and then 1. And then we have 2 and then 4. Now, these values represent 0.5. Okay, so now that we've graphed, we should know that this is a parabola that has these arrows, which means that it's continuous. Okay, so the first thing we want to do is we want to find what the domain is of this function, and then what is the range of the function. So let's go ahead and do that. So for the domain, it's going to represent the numbers on the x-axis. So it continues to the right with an arrow, and the same thing on the left with an arrow. So that means it's all real numbers for the domain. So we can say it goes from negative infinity to positive infinity, or we can say that x such that x is all real numbers. Rewrite that again. Okay, and now for the range, we are looking at all the y values. So the y values start at 0, and then it goes all the way up to positive infinity with an arrow. So how do we write this as a range? Well, that means we're starting at 0, so we have a bracket at 0, and it's going all the way to positive infinity. Or if we wanted to write this in set builder notation, we would say all the y's such that y has to be greater than or equal to 0.